Well, hello everyone. My name is Igor Starkov. I'm the Vice President of Digital Twin at Siemens. Some of you know me. I've been with Ecodomus before. And first, I wanted to introduce the topic for today's presentation: digital twins and golden thread via lifecycle BIM common data environments. So first, we will go into explaining who we were and who we are now. We were Ecodomus Inc. California corporation, and we were acquired in February by Siemens. So we are now part of this huge organization. We continue to develop our product, which still continues to be called Ecodomus. But the purpose of the Siemens acquisition, of course, was to develop an ecosystem where our product, our enabler of digital twins, works with the other Siemens products and the other products from the industry. So it's not like we are limited only to Siemens, the BMS, and the other technologies to build a better digital twin for the end users, for the customers, like the ones that you've seen in front of you. We worked on this topic for more than 12 years. So we were the first company to do that. We continue to be the one that has the most advanced technology for building a BIM-based digital twins. Everybody probably hearing a lot about digital twins. I wanted to just remind how we perceive that, because I've seen digital twin definitions. Some companies are creating a point cloud and they call it a digital twin. Some put a few hundreds of sensors and call that a digital twin. For us, it's all of the technologies that define the facility and the processes related to the facility combined. So it's more of a system of systems or system of applications and databases together that create a digital replica of the physical assets and processes and people. The smaller number is probably familiar with the term golden thread. The golden thread is again, the definition is in front of you. It's a formal process to maintaining digital information throughout the whole life cycle. What it means in real language is if you started defining an object during the early planning and design stages, the same attributes, the same names are maintained throughout the construction, commissioning, and operation and maintenance. So we don't have to rename, retype information, which causes typically extra costs, and usually it causes the information to be duplicated, triplicated, and impossible to analyze later. So we see this effort right now being solved at the level of open standards, which we will also discuss. But at the same time, with the existing products, we also can now solve this issue of golden thread. Why would people use digital twins? Why is it getting so popular? Because it allows you to see how some physical structure is supposed to work and how it actually works. So you combine the results of your BIM authoring applications and BIM simulation tools with the sensors and the SCADA systems developed and installed by traditional vendors, right? So if you see that some area of your facility is not performing as it was supposed to be designed, some actions will be performed. In order to build digital twins, you need to have systems that are able to handle that massive amount of objects and their attributes and properties. So you need a common data environment. Common data environment that we have is slightly different from the traditional design-oriented common data environments like you are familiar with, like BIM 360 Docs and ProjectWise and a few others, because we focus more on the object attributes than just on the files. Right? So we do take care of the files, but we are more interested in what is inside of those files. Right? We are interested in both product information model and asset information model, and we focus on the whole life cycle, so not just on a specific stage. When the information throughout the project is collected, the digital twin for the life cycle is traditionally, like I said earlier, it's a system of integrated systems. Right? So we traditionally integrate applications like IBM Maximo and SAP and Infor, EAM with the products from Siemens, Honeywell, Johnson Controls, Schneider Electric. As you can see, this roundabout with all this information is supposed to flow bidirectionally in all of the directions. And that's what pretty much digital twin is. Our perception is, you ask a question and the answers received usually collected from all of these different applications. So your level of the quality of the information is much higher than if you just use one application separately and then another application, the third application. We get rid of this siloed approach. All right, so here's an example of one of our projects before. It's a digital twin that was created for a wastewater facility. And this was done using Nicodomos API. So the customer used the original Revit model and then looked at how they can connect that model to the other sources of information, right? So in this case, they extracted data from Revit, but also connected the data to Maximo, CMMS, and extracted data, exchanged the data between those two applications. Even you can jump from Nicodomos to Maximo, from Maximo to Nicodomos. OSI Pi server from Aviva, which is now Schneider Electric. Inflow, it's the open text documentum, EDMS. So as you can see, different types of applications show the data in the same kind of single pane, single glass of view, where you can see the data from historical data from the data from the sensors, as well as all of the documentation, all of the other information like work orders. But at the same time, you can do traditional things that you would do in the BIM, like measuring, sectioning, hiding objects, highlighting objects, etc., etc. So to get that data collected, like I mentioned earlier, you need a common data environment and the concept of the golden thread, right? So we enable that process by establishing the milestone-based quality control process. So during the design stage, what we can do is after extracting the data from the various BIM files, we can validate whether that information provided by architects, engineers, consultants is matching the original plan. And if this model is ready for the handover to the construction stage. Within the construction stage, we do a similar job. We check if the model data is relevant to that milestone and whether it's ready to be handed over to operation maintenance. How that quality control process works, I'll show you in a few slides from now. During the operation and maintenance, the models can be used as a traditional BIM for FM toolkit, right? So various use cases, which we'll also review. And for renovation and upgrades, you maintain that digital twin live. So the next team that comes in a few years to do some renovations, they can see the same data sets, the same templates, and the model continues to be improved. This is an example of one of the projects we've been doing for the largest infrastructure project in New Zealand. Nicodomos here is used as the common data environment for the construction stage. So here, construction teams are using it to collect the data and validate the information and do it both in the office, in the traditional browser environment, as well as on mobile tools. And we also integrated here with Aconex because Aconex is a very popular tool for file storage, right? So we extract the data that have been approved in Aconex as the submittals, and those documents later linked within Nicodomos to the data, to the BIM objects. So by making this happen, the handover contains all of the relevant information, and at the same, it's BIM driven. Also, the application is used for digital inspections. So this is our mobile app where forms are filled out, and of course, filling out a PDF on an iPad, it's not new. It's been around for 10, 15 years. But these forms are intrinsically connected to BIM objects, again, to systems, to zones, to individual instances, to different types, etc. In this example, a field user taking the photos that are also associated with the BIM objects. In this case, the user fills out, creates an issue Again, issues creation in the field on iPads is not new, but the way how we connect it to the BIM is pretty sophisticated. Again, so all of the issues are continue to be BIM driven, connected to the assets, connected to the systems, and they can be part of the package, of the handover package, or may not be. Red lines and markups are also updated on the iPad within Ecodomus Mobile, and they also attach to the BIM objects. So this closeout pack is not just electronic, it's completely BIM enabled, right? So when the owners get the handed over information, they get obviously the BIM, but they also got pre-validated high quality data that is aligned with the owner's requirements, right? So this was done for the rail job, but the same approach is being used for any other kind of facilities. It's important to remember that 3D and 2D BIM is not just 3D. These single line diagrams are also quite valuable. So we have the ability to process, integrate kind of a 2D diagrams. Like here, I'm clicking on that reactor, and the reactor opening up an asset page for this reactor where you can modify the attributes that are being collected for this asset. I can see all of the field construction issues related to this reactor. I can open up and say, show me that specific reactor in the model. So it will load a 3D file, and we'll find within that 3D model that specific reactor, shows its properties on the right. And if you want to see which pump controls that specific reactor, you can see that through the relationships module we call effects. So I see that that's the pump that is upstream from this reactor. So I can jump to that pump and review its properties. And this is the pump that I can see also on my 2D diagram. All right, so why people do those digital twins? Why are they creating it? It's all driven by specific use cases. So it's an extract from one of our projects for the healthcare system in the United States, where the interviews were performed related to different processes, and the savings identified on time and costs. And this was used to prioritize which cases will be first priority, second priority, because you create digital twin for a specific process, not for abstract everything, right? Different types of facilities as well. It's like I showed you a few examples, rail and the buildings. It's been done for bridges and oil and gas, but of course, majority of those are traditional buildings. The models created, most of you who are familiar with BIM, you know that a design model is different from construction model, different from the owner's model, right? So the owners need to understand that in order to get the model that they could maintain over the period of the life cycle of the building, they need to request that and pay for that, right? So fortunately, right now, it's doable to maintain those models in a single set of files. That's a different topic. I will probably speak separately on this, but it can be done for both brownfield, existing facilities, and greenfield, new buildings. So it doesn't really matter when you start. It's just the issue of time and money. Yeah, you can build a pretty sophisticated digital twin for an existing facility. It's just going to cost you twice as much as if you do that from the beginning of the construction and design. Project standards, lifecycle standards, and why they're important. So typically what we see in the industry is because the quality of the requirements are low, you have issues with the data deliverables. Schedule is always behind the schedule, etc. So in order to avoid all of those issues, you need to specify your information model requirements, preferably using open standards like ISO 19650. Right now, it's been published as an official global international standards. So you probably are familiar with terms like asset information requirements, asset information model, etc. Right? So our personal experience is the best results are where you have a very detailed level of specification. So when you explain everything in your contractual documents in terms of the namings, in terms of what exactly you need to get, the better results will be. Like if you just say, hey, give me a great digital twin for my building, it doesn't mean anything, right? So, so for the average BIM project, you will get what typically is useful for construction. right? So we focus on what is useful for the owner, and it's a significant gap, right? How to check the data? This is an example of one of the simplest asset information requirements that I've seen. As you can see, these are the attributes. These are the fields, fields needed for these asset types. And we, within our environment, we can specify those requirements. We can specify which fields needed for, let's say, pumps, for valves, is it for a type or is it for a component? And when you open the profile for a specific asset, you see exactly those fields that are needed to be populated. And you can specify requirements for each stage, like during the design completion, I need this attribute. During the construction completion, I need these attributes and these documents. So when we run our quality control report, we can see what assets are missing which values. Like I see that this pump is missing this field and those two documents. This valve is missing those three fields and those two documents, and I can upload them within my CDE and all of these missing documents and all of these missing attributes, and I'm satisfying the requirements that have been placed on me, right? So all of that is a part of the traditional QC process. The other things that I find useful are filters or custom saved queries. Like search sets in Navisworks or something similar, you can define based on any of the predefined fields, you can define the formulas, save those formulas, and you can run them. Like in this example where, let's say I'm out of 3,500 elements, I'm only interested in VAV boxes that cost more than $200. It's a simple formula, so I can run it, and it finds those 15 objects that satisfy that condition. Or show me the assets that have been commissioned in January. And those are the assets that have been commissioned. And you can run the same queries within the model viewer. So it shows you those 15 VAV boxes here highlighted in the model. So it becomes a kind of a visual dashboard for your queries. You can say, show me the items installed yesterday and add items installed last week. And you can see them here just by building a simple query. The language required, this is something that sometimes customers asking us, they said, well, I like this idea, I just don't know how to ask for that. Well, we have some templates that we can share later if you're interested. Documents, when we talk about BIM a lot, we either talk about the 3D Revit model or we talk about Navisworks published model, rarely talking about documents. Documents are part of the information model because you describe information, it's just not described as the visual or not described as the parametric attribute, but so we have to make it a part of the deliverable. So that's why we have a built-in document management solution where all of the documents can be connected to the different types of BIM elements, right? Whether it's individual instance or in the BIM terms, it's called component, right? Whether it's a type, space, zone, system, floor, etc. In addition to just storing those documents, we of course allow to do the 3D markups and check in, check out, and having the built-in workflow where you can customize how the notifications work if this document changed its status from published to archived or whatever. There's even a comparison tool that allows you to compare different PDF versions one to another, so you can see it in real time. So the issues management, it's kind of a task management solution because every time you work with the cleaning the model or reviewing your 3D virtual model, you have the ability to create a notification of some sort, requesting for more information or noticing that something is wrong. So this can be done within the model with the markups. I've seen guys that a lot of companies do that right now. For us, it's just one small module. You can do that in Point Cloud if you want to, like in this example where you observed that something is wrong with this fan, and this fan is automatically attached to an issue. So issue can be generated. You can 3D markup, and you can send it as a BCF file if you want to exchange it with the other systems. And each issue created has the ability to attach photos, markups, and you can track the history of those activities. When we integrate all of that information, remember the previous slide about all of the systems working together, obviously we recommend to do that not via the exchange of Excel files or even CSV files, but like XML-based API-driven real-time bidirectional integration. Right? So that's what we know, of course, that there can be a Revit can publish COBie Excel file, and you can give the COBie Excel file that can be imported into something like Maxim or whatever. We typically consider that as not the right approach because it lacks the quality control, it lacks the bidirectionality and updates. So that's why we typically integrate using the direct APIs, mapping the fields and exchanging that information. How we extract the data, we use our own plugins using the Revit API and other APIs to get the data out. And then we populate the other applications based on our integration with those applications, whether it's Oracle Unifier or some other system. On the GIS side, we used a couple of approaches. We have this embedded SGRGIS plugin where you can associate each section of the visible 2D shape files with the elements of the BIM model. Within this concept, what I mean by BIM model is the aggregate collection of various files. So this, what's loading right now is a view that contains a few dozens of IFC files for the underground utilities. You see all of this piping was designed in the Autodesk Civil 3D and 12D, which is another Civil product package. Above ground station was modeled in Revit, as far as I remember. And then the rest of the view, as you can see, there's a point cloud taken from the aerial drone scans. So you can see how your model fits into the neighborhood, so to say, right? So like you see, we started from, so on the right side, you see those attributes for each object. These attributes have been specified by the client, by the owner. And so you can turn on and off all of these files that combined together represent this image. Okay. Or another approach to the GIS using the other like Mapbox and other technologies where you can place your buildings on a map and define the level of detail depending on your preferences. Like in this example, for this building, I have a detailed model, so I can select individual lighting fixture and say, show me where's the circuit, what's the circuit number, and where is the panel board to turn off the electricity for that lighting. Here is the panel board, right? And on mobile side, definitely there are tools that allow you to navigate within the model online, offline as well. Fill out the forms, fill out the issues, use the QR codes or barcodes, and perform the work in the field. I'll skip that one. On the Internet of Things, there's a big development right now everywhere. Sensors are getting cheaper and cheaper, so you are deploying them and connecting them to the model. The benefit, again, like I mentioned earlier about the digital twins, you have how it's supposed to work, so your simulation and how it actually works based on your sensors and meters data. And your information from the BIM and from the commissioning and engineering helps you define whether it's working well or it's not working well. Right? So the other approach is to visualize your BIM model by adding sensors onto these blue panels. I added within the Nicodemus interface on top of the assets that were imported from Revit. And here we show that they can be changing the colors, they can blink, and the data is updated every 30 seconds in real time from the sensors in the respective mechanical room. All right. Other types of sensors that can be integrated are presence sensors that show the number of people in a specific zone, the video, CCTV streaming. So all of those are extra things that can be used within the BIM environment, within the digital twin environment. I showed you earlier how the BIM 3D model and point cloud can coexist together. So in this example, you see this is the mixed environment. Part of that is 3D BIM, part of that is point cloud. So it's a kind of a semi-BIM, I would say, right? And future developments like adding your own assets within the model, if they're the ones that are created within Revit are not enough. So you can place those shapes. In this case, these are, let's say, sensors next to the door, and you can link them to the database and they become intelligent objects. So these kind of opportunities also exist. I showed a bunch of things. I covered topics of what digital twin we perceive as a digital twin, right? So I think I'm ready for questions and answers. My contact info right here for those who want to read more. We've been covered, our projects have been covered in a few books in the industry, from the first BIM for FM book published by IFMA and Paul Teicholz to the recent one by Chuck Eastman and his team. We have 3 projects covered in this BIM handbook. If there are any questions, I'll be happy to answer them now.
Great. Thanks, Igor, for that presentation. We do have a couple questions. The first one from Jeff. Now, would the owner be able to use Ecodomus to improve business processes, production or service design, as new equipment or products are being developed?
Interesting question. So how I understand it is that you're referring to the digital twin, not just about the core and shell of the facility itself, but also of the equipment inside of that facility. Yes, I believe it is something that we've been also looking at. It's not very popular yet because there are typically in large organizations, those are different departments. Like I remember I once showed a customer of ours. They were a large supermarket chain, a French supermarket chain, and they sent us a model of the supermarket. I loaded in the Ecodomus. I showed them things that they wanted to do about HVAC, but I said, well, I can also place products on your shelves because they had shelves models inside of that supermarket. And I said, I can track your shelves products. They said, that's not our department. We're not interested. But in reality, I think that's what they would save most money on if they would showing the real-time status of their products on the shelves. Right. So similarly, it may be a part of the, let's say, a car manufacturing company. You develop the new types of robots, so new type of conveyor belts, or maybe in the airport, it's the baggage handling equipment, right? So you show again how those things change. It's part of the digital twin for sure. It's just we need sophisticated customers who would be interested in implementing that. Technology is already there. I think right now we are, before maybe 20, 30 years, customers were pushing technology to catch up with the business processes and capabilities of the employees. These days, we are, as technology, we are further ahead of what the regular users can use and can absorb. We had situations where we developed some great feature from the technical point of view and realized that for the average technician, it's just too complex to use that.
Right. Right on. So it's really raising awareness in the industry.
Training employees to become more IT savvy. Fortunately, with the newer, Facebook generation that is joining the workforce right now, it's easier because I remember in my previous company, Latista, when we were introducing the first tablet PC based for construction in 2004, 2005, they didn't even understand that it can be, what the tablet is and how it can be worked on. And they were complaining that when people see the computer, they think it's somebody watching TV during the day. It's definitely the new workforce will drive this adoption of tools, and fortunately, it's happening as we speak.
Right on. Okay, another question from Akash. Could we use the platform as a one-stop solution to import the build model, pull in dynamic real-time data through IoT, and analyze and take actions all in one flow?
Yes, I actually showed you a few examples of that. The thing I didn't show is how you can actually control the actuators or things. And it's typically not the technical issue, but the political ones. We were asking if we are, will the BMS owner will allow us to, let's say, change the settings on the thermometer or the thermostats or something like that. And they were saying no, because we own the warranty on that equipment and we don't allow the third parties to change something. We can only allow to read the data. So what traditionally is being done is they use it almost to view that thing to make a decision, and then they jump into the control software of the specific vendor, whether it's Siemens or Honeywell or something like that, and they change the settings in that application.
Right. Okay. So following up on that, who has the responsibility to confirm that the data in the model conforms to the real data on site?
That depends, of course, from the project to project. Sometimes it's ideally that would be commissioning engineer, but commissioning industry in general is very backwards right now. So I haven't seen a lot of them being involved with that. They still consider themselves, hey, we are like Microsoft Word writing specialists. We write the tests and somebody like. So right now it's usually done by third-party outside vendors that the owner hires to represent their interests, because the few owners we worked with got burned a little bit when the contractors were saying, hey, don't worry, we'll give you beautiful BIM, it will have everything in it, and the owners then realized that it was not the case. So right now there are the same way as in the general construction, you have CMs, construction managers, representing owners' interest, working with the contractors as owners' reps. We see that moving into the virtual arena right now. So there are specialists, they call themselves either data curators or virtual agents or whatever. They make sure that the models are matching what the contractor says they built, right? Because they do laser scanning, they do merging of those models to verify the data. They run the QC on the attributes of objects to make sure that all objects are located in spaces and they're all part of the proper electrical system. There's quite a lot of work.
Yeah, I bet. Right on. Okay, question from Jose. How the contractor can provide access to the owner in case the owner doesn't have the system established?
Sometimes, including with our customers in Canada, the owner is asking the contractor to buy licenses for them. Right. So then, so it's the same environment, the same workspace. You just add more licenses that the customer, or you're novating licenses that you used for the construction, you move them to the owner. So the owner is now having access to the same information. So that's why it's common data environment. So you decide who wants to be a part of that common environment. You may include an owner, or maybe include a facility management firm if you outsource all of that to external facility management company, or you both are. So it's a transparency, right, of what information you want to share with them. You may hide some information. You may say, no, I don't want this information to be shown because it may be secured facility, right? Like some government entities. So
you've got a lot of control over who sees what.
Yeah, so that's why you need to have user roles and permissions to enable that these people cannot change it. They can only view that information, which typically doesn't exist in the world of Revit and Excel files copy exchange, right? So it's just files. So one of the reasons we kind of don't like that Excel approach.
Right. Okay, question from Abdul. How the changes will be updated, whether it's in a viewer model by the FM coordinator, and if so, how the changes will be updated in core AIM models?
Mm-hmm. So the changes, we assume that there are both project changes during the construction, and there are changes related to just natural renovation after the project is over. It's an FM stage, right? So this is within Revit, we use the phasing to update the models to see what has changed in the model, right? We have different types of IDs that we track. In terms of the process itself, again, some clients have internal BIM modelers. So if there's something changes in the model, they update it internally. What the best practices we've seen is the availability of templates. So each owner has their own Revit templates with the pre-populated attributes. And so when the new architect engineers are started working on that, they from the beginning they have the proper asset information requirements embedded into their Revit files. Because if they come to us, the Kadomos, we will of course point out all of these problems, but a smarter idea is to have them from the beginning versus telling them, hey, you've been working on this for 9 months and you have 2,000 errors. So they have to come back and fix it all. So having templates definitely precludes them from having those errors.
Right on. And also would support like your clientele, right? Here's a platform to build on with templates for simple ease of use.
Yeah, there are a few companies right now that selected this approach. They are building the template building solutions, right? So they kind of, so as an owner, you subscribe to some online service. That online service generates those templates, and you share with your providers, your architects, engineers, contractors, the same template, and everybody's on the same page.
Right on. Okay. Another question from Jose. Where's the data located? Is it linked to the BIM or third-party application?
No, the data is located in its in Ikadomo's backend SQL database. So we use Microsoft SQL database as the where all of the attributes is stored, and the files themselves are stored on application server, and they are indexed within the Microsoft SQL database. That's why we can integrate with the other applications like Maximo, SAP, etc., because this is just database to database talking via web services. So we're not, we extract the data. Like one of the slides I showed you shows how we extract the data from IFCs, from Revit, and from other types of files, Excel files, and so we have a control of our own database.
Right on. Okay. Last question from Akash. Essentially, efficiencies to the digital twin. Let's see. How can I summarize this one? Building life cycles, operating teams, equipment with capabilities to deliver the efficiencies.
I'm confused about the question, to be honest. Is the question about whether the operation teams are capable of using digital twins, which is a good question, by the way, because not every customer has the workforce that is capable of using digital twins. So you can build a great product as the great file with all of the data, give it to the client, and they're like, what the hell is that? And they just, it puts it on a shelf. We've had some examples like that, because if the customer did not have any processes where they needed to utilize the data, then it's going to be shelfware. So it's important to stay with the customer post project and making sure that they know, you know what they use it for, how they use it, what kind of challenges they encounter, and helping them to solve it. Because it's not just buying a software, buying a book and learning how to use it. It's a business process change. So that's why it's so painful. Like I said, we've been doing it for 12 years and we still considered early in this transformation stage. So primarily because, it's not about just learning the features of the software. It's also changing your business process.
Yeah, which comes back to change management, right? Integrating the platform to be utilized efficiently and effectively.
That's right.
Excellent. Right on. Well, thank you very much for your presentation. Certainly very informative, and we had some great questions there. And thank you for answering those questions for us. We will be moving on to our next presentation after a brief break.
Thank you so much. All right. Bye-bye.